Hello students, we will do the water, the essence of life, which is from the book Wanderer's World, Unit 1, Life Around Us. We will do the question answers today. Discuss. Do you think we can drink the water present in the oceans? The high salt content of ocean water makes it unsafe for human consumption. We would have to urinate more water than we drank in order to wash out the excess salt because our kidneys can only make urine that is less salty than salt water. This would cause severe dehydration, which can be fatal. Actually, consuming ocean water will simply increase your thirst. Okay. What can ocean water be used for? Ocean water uses. Ocean water can be used for many purposes, especially after being desalinated. Even though it is not fit for human consumption. Drinking water and public supply. In many coastal areas with limited water supplies, desalination is an essential procedure that turns ocean water into a dependable and safe source of drinking water. For instance, a sizable amount of the public water supply in Middle Eastern nations is desalinated. Applications in industry and agriculture. Desalinated water has several uses in manufacturing and petrochemical industries as well as in irrigating crops in arid areas. Thermoelectric power stations and certain mining operations use saline water for cooling. Resource extraction. A variety of commercially significant elements can be found in abundance in the waters. Seawater can be used to extract salt, magnesium and bromine. The possibility of recovering precious minerals from the brine left behind after the desalination process is also being investigated. Other uses. Ocean water is utilized in aquaculture and as a source for food items and cosmetics. Among other applications, it also contributes to the production of tidal energy and is essential for controlling the planet's climate and weather. Activity 1. Where can we find fresh water? Identify the different freshwater sources from the images given below and write their names. Answer. Around the world, fresh water can be found in a variety of natural areas and bodies. Since rivers and streams. A crucial component of the water cycle are rivers and streams, which are flowing bodies of fresh water. They serve as the main supply of water for industry, agriculture and cities. Lakes and ponds. The size of lakes and ponds, which are bodies of standing fresh water, varies. They serve as drinking water supplies, recreational areas and habitats for a variety of aquatic species. Ice caps and glaciers. The polar ice caps and glaciers contain the world's biggest frozen freshwater supplies. Their meltwater feeds lakes and rivers, however, it isn't usually readily accessible. Groundwater. Water held in aquifers, which are subterranean layers of rock and soil, is known as groundwater. For many people around the world, it is an essential supply of drinking water that may be reached by boreholes and wells. In addition to these natural sources, humans also create reservoirs and dams to store and manage fresh water for various purposes, including power generation and irrigation. Activity 2. Take a steel glass, put some ice cubes in it, observe the small water droplets forming on the glass. Question number 1. A. Where do these water droplets come from? Answer. The water vapor in the air around the glass is what causes the water droplets on its exterior. The water vapor in the air cools when the warm, humid air finds touch with the cold steel glass surface. As a result, the gaseous water molecules slow down and lose energy. transforming from vapor to droplets of liquid. We call this process condensation. What happens to the ice cubes after they are left in the glass for some time? Answer. The chunks of ice will begin to melt because steel glass conducts heat well. Heat from the surroundings is rapidly absorbed by it. The frigid ice cubes then receive this heat. The ice cubes transform from solid, that is ice, to liquid, that is water, as a result of their molecules gaining energy and becoming more mobile as a result of absorbing the heat. We refer to this process as melting. Question number C. If we heat water, what will happen to it? Answer. Water will change phases if it is heated. The molecules of water acquire energy and accelerate. The liquid water will start to transform into a gas known as steam or water vapor when it reaches its boiling point, which is 100 degrees Celsius or 212 degrees Fahrenheit at sea level. This process is called boiling or evaporation. Until all the water evaporates, it will keep turning into steam. In the above activity, what forms of water do you see? Answer. In the activity, you observe water in 3 different forms, which are the 3 states of matter: solid, liquid and gas. The 3 types of solid: ice, water. The solid form of water is represented by the ice cubes you put in the glass. The water molecules in this state are firmly packed together and organized in a stable crystalline shape. Water, liquid. The ice cubes melt and become liquid water. Condensation creates liquid water, which is also represented by the tiny water droplets that appear on the glass outside. Although the molecules of water are closer together in this form than they are in a gas, their ability to glide past one another is what gives them the property of liquid. Gas, water vapor. The invisible water vapor in the surrounding air is what causes the water droplets on the glass outside. The gaseous form of water, when the molecules are widely separated and free to move, is called water vapor. The entire procedure shows how water may transform from a solid to a liquid, and how the air around us is constantly in the gaseous condition. This process of water changing states is a fundamental part of the water cycle. The 3 forms of water are a key concept in understanding Earth's climate and ecosystems. Activity 3. Take a transparent bag, use a marker to draw the sun, clouds, trees and arrows on it as shown in the picture. Fill 1/3 of it with colored water. Tip: you can use blue paint or food dye for this. Seal the bag tightly to prevent any leaks. Place it in the sunlight. After a few hours, observe the changes inside the bag. These findings and scientific justifications are based on the activity. I observe. You see the colored water at the bag's bottom warming up. Water droplets created within the cover. On the bag's interior walls, you can see tiny, transparent water droplets forming. Droplets may mix and flow down the bag's sides as more form. I wonder what causes water to warm up. The sunlight causes the water to warm up. The colored water absorbs the light and heat from the sun when it travels through the clear plastic bag. As a result, the water's temperature increases. What is the source of the water droplets? The water at the bag's bottom is the source of the water droplets. The colored water turns from a liquid to water vapor, an invisible gas due to the heat from the sun. We refer to this process as evaporation. Then inside the zipped bag, the water vapor rises. The vapor cools and transforms back into liquid water droplets as it rises and strikes the strikes the colder plastic surface. We refer to this as condensation. We refer to this process as condensation. The water cycle, the constant flow of water on, above and below the earth's surface, is perfectly shown by this easy experiment. The bag serves as a miniature earth system, demonstrating how the energy from the sun causes evaporation, condensation and precipitation, the water flowing down the bag's side. Activity 4. Take a transparent glass, fill half of it with soil, slowly pour water into the soil using a spoon. Observe what happens. Answer. The following observations and scientific justifications are based on the action that was described. I observe the soil absorbs the water. You will see that the water initially vanishes into the ground. The water is absorbed by the soil particles. Bubbles of air climb to the top. The air that was trapped in the crevices between the soil particles is forced out as the water fills them. As a result, bubbles are produced and rise to the water's surface. The dirt darkens. The color of the soil will darken as it absorbs water. I wonder, why does water get absorbed by the soil? Because of its many microscopic gaps or pores between its particles. Soil is porous. Because of these holes, the soil can absorb and retain water like a sponge. For plants to flourish, the soil's capacity to retain water is essential. From where do the bubbles originate? In reality, the bubbles are air trapped in the dry soil's pores. The air is forced to rise and escape as bubbles when water is poured into the soil because the water displaces the air. This easy experiment illustrates a basic idea in geology and agriculture. The porosity of soil or its capacity to absorb and retain water. It also demonstrates that soil is a mixture of solid particles, water and air rather than a single solid mass. So students, I have completed up to activity 4 and I will upload the next video. The more activities which are given in the book, I will solve it and upload it. Thank you.